Cool. Good evening, everyone. So welcome to this session on programming with C++ STL. So first of all, I want to congratulate everyone for making the DSC till now very successful, at least in our campus. We have conducted many events and many programs as well, and in future we are also conducting. And thank you for everyone attending, especially in the midst of semester exams. You guys giving me so much spirit to teach the classes. Honestly, I haven't expected this much count, but now it's my responsibility to teach well. Okay. So today's topic, as you might know already, we are going to discuss on C++ STL. So this will be the agenda of the session. So first we will be looking at introduction to STL, like what is STL? Before learning anything, we need to learn it, right? Just understand what the name. And the next thing that we're going to discuss are templates. And the next thing, examples for templates. Like instead of just explaining templates, I will show you examples like how to use templates. And later we will be jumping into the components of STL, and later we will be discussing on containers and algorithms. Containers we will be discussing vectors, stacks, queues, algorithms. There are many algorithms: sorting, reverse, count, find, binary search, and all this stuff. So that's the agenda for this session. So let's get started with the first one. So the first thing we need to discuss is what is STL, right? So, so to simply sum it up, STL means Standard Template Library. So what's meant by library in general life? A library is something, it has a collection of something. Book libraries generally we will, in general world we use library for collection of books, right? Library contains of so many books. So similarly, Standard Template Library, which means it contains a collection of templates. What templates? The templates are nothing but simply if you know, there will be some video templates. If you edit videos in the past, you might know there will be templates, right? A template is nothing but simply it is an pre-cooked template. Means someone already did a work on some project. You can use that project directly. Best example is GitHub. In GitHub you can fork other projects, right? You haven't need to write any code. You can simply fork that project. So the repository which you are forking is called a template, which means it gave you a base project which you can edit later. So simply templates are nothing but these are some predefined functions which are did by the C++ compiler itself. So instead of writing the code for all parts, we can reuse those functions and all those stuff by importing simply. Uh, so that's the introduction to STL. Not much. Once we get into the main part, you will understand. So before going into STL, I just want to clearly explain you about templates. So are you familiar with templates? Please let me know in the comment box. Meanwhile, I will just change my tab. Okay. Is my screen visible? Is the compiler visible to you?
Yes, visible.
Cool. Okay. So first of all, before going into STL, as I told, STL standard template library, right? So before going in depth into STL, we need to know what is template, what is the use of template, how to use templates. So that's why I will just give you a short introduction to templates. So observe this function. Oops, sorry. So what will be the output for this program? Please type it in the chat box, guys. Please unmute everyone. Sorry, mute everyone. What will be the output? Please mute yourself. Cool. So the output will be 5. Exactly. So now tell me what will be the output? What will be the output? Tell in the chat box. 2.4 and 3.4. What will be the output? Error. Okay. Error. Okay. Most of you. Let's see the correct answer. Oops, it's taking some time. Okay, the output is 5. Why 5? Simply 2.4 plus 5.3.4 will be 5.8, which will be typecasted into an integer. It will be rounded to 5. That's it. Type conversion, changing of one data type to another data type. This is implicit, right? Which means uh, float is larger than int, right? So it will be automatically converted. So now tell me the output. Now let's see who will say the correct answer. What will be the answer? Add of a comma b. Type it in the chat box. I haven't getting answers. What will be the output for add of a comma b? Just guess. A b. Nice. Any answer? Anyone? Anyone else? Please be interactive. Okay. Error. So here we can see some multiple versions of answers are coming. So now let's see what will be the answer. Even I was also very curious. The output is 195. So what has happened? Exactly. A will be converted into its respective ASCII code, and B will be also converted into its ASCII code. What is the ASCII code of A? 92, I guess. Sorry. 97. B will be 98. So both will be added, and 97 plus 98 will be 195. So now tell me the answer. So what will be the output? 97. Okay, got it. So what will be the output now? Add of hello comma guys. Please be quick. The time is ticking now. I need to explain STL also, right? So what will be the output now? Add of hello comma guys. No, error. Hello guys. Error. Hello guys. Error. So my guess would be error. Oops. I don't know how it came. Sorry. So as you might see, the output is not as we are expecting, right? So why is this happening? So because C++ is a statically typed language, which means we need to give the data type that we are passing, right? So if I'm passing 1 comma 2, whatever we pass in the arguments, those will be converted into integers, right? As I'm taking integer parameters here. So that's why uh, the output is not coming properly. So if I want to add two float numbers, what I need to do, I need to write another add function. This time I need to give float parameters. So float a comma float b, c out a plus b. Sorry, right? So to call the function, add 2 of 1.1 comma 2.2. So now see the output. Sorry, I need to. uh, so as you can see, now the output came correctly. 1 plus 2 will be 3. 1.1 plus 2.2 will be 3.3. So this is the issue we got. Uh, the logic that we are using for the both functions is same, but we wrote two functions because the data type of the parameters are different. So this is where the issue has come, and the templates are used to solve this ambiguity problem. So templates are generic data type, which means instead of writing different functions for different data types, whenever we have the same logic that we need to perform on different data types, we can use templates. So what do templates do is simply they will create a new data type, and simply we can pass the data type for whatever data type we want. So the data type that we are going to create will be a superset for all integers, floats, and characters, strings, whatever you. So we can write one function for all data types. So that's the main advantage of using templates. So now let's see how we can create a template and do the same problem with just one function. So I won't go into depth. So to create a template, we need to use the template keyword and class, whatever you need. So what it essentially do is it will create a data type, new data type called T. So that the data type name will be T. So wherever we need to use the data type, we can simply call T instead of writing int, float, and all the stuff. So now the function will be void add instead of int a comma int b. This is the function, right? Cout add of a plus b. Instead of giving data type here statically, what I can do is replace it with the data type that I have created, ta comma tb. Now see what will happen. I will comment this function first of all. I will check whether this function is working or not. Add of 1 comma 2. So check the output. So what is the output? It came nicely 3. So cool, it's working. So this is the magic of templates. So now I will show you the real magic of templates. I will uncomment these lines. Now I will use the same function for float values. Add of 1.1 comma 2.2. So without using templates, the output that we got is 3, right? Now see what will the output. Sorry. Okay. The function name is add, right? So the output will be 3.3. So magic. I haven't wrote any other function. I simply change the parameters. So this is how templates work. You can also pass strings, integers, I mean characters as well. Let's try for hello, comma world. We got some random number, right? Minus something. I don't know what will be the output right now. Okay, this might not work because I need to import strings and all those stuff. Let's check with characters. A, comma B. It's automatically converted into integers. So I will tell you later how we can do with strings and all the stuff. I haven't imported the strings, that way it is converting into integers. So this is the main section. Like we can reuse the same function for whatever we need instead of writing all those same functions again and again. We can simply replace it with the newly created data type that we can use anywhere else. So that's this is a function template. So templates are two types: function template and class template. Uh, it's not in like this is the just introduction of templates. Let's now this time I will also tell about some templates. The time won't be enough. Just okay. Now tell me, is this everyone understood what is template? So first of all, what will be the use of function template or just template in normal sense? This is the main advantage of templates. We can use the same function for different data types. That's the cool part of using templates. Nice. Okay. Looks like understood everyone. Okay. Now I will jump into the standard template library part. Or else if you need any other example, I will try to do that. Uh, okay. Now what I will do is I will create another function like int add int a comma int b. Now I will return the value int a plus b. So in the main function, how should I call it? Int c equals to add of 1 comma 2, right? So the output will be returned to C. So the shortcut to remove a templates is very easy. Wherever you found int, float, char, any data type apart from void, I'm telling you just blind shortcut to convert a normal program into template program. To convert a normal program into template program, first of all, add this line template class T, and wherever you find in the outside of main function, not inside the main function, outside main function, wherever you find any data types like int, float, characters, and all the stuff, simply replace it with the data type that we had created, even for the return type as well. TTT, that's it. The program will be run as usual. I will just print cout C. So that's it. The output I have implemented. Sorry. Cool. 3. So this is how templates work. I hope everyone understood what is templates. Now I will move into this next agenda. So what is our agenda next? So I will check this box. Everyone, should I check this box? Introduction to STL. What are templates and as well as examples for templates. Any queries till now? If you have any queries, please ask right now. Once we go into STL, I can't come back to templates. Okay. So let me do one thing. I will also tell you how to use the class templates as well. So class templates. So simply create a template class T. So remember the T will be the data type that we are using. It is the new data type that we had created. We need to use for all functions. Now I will create a class A, public. I will create some variables. As you can see, I had created a variable with the data type that I had just created, TA. Instead of int A or int B anything, I can simply use TA to create a function TA, sorry, A comma, TB comma, cout A plus B. So now I just created a class. Now comes the tricky part. As I told you earlier, simply replace the normal program would look something like this, right? Int A, int add, and all the stuff. In templates, we need to just replace it with the data type that we had created. And the only change comes here in the main part. So whenever we're creating classes, the thing that we need to do immediately in the main function is to create an object, right? So a class can't exist without object. So in general, this is how we create the objects, right? A space OB, right? A space OB, and we call the functions as OB.add 1, comma 2. So this is how we will do in normal programs. But in STL, sorry, in templates, no, the class, the function is not a normal function. It is a template function, right? So whenever I'm creating the object, I need to pass the data type as well. So simply, this is how I will create an object for a class template. So the class name will be A OB. I will just compare it with the normal syntax. So this is the syntax for normal classes. This is the syntax for template classes. So this is the syntax for normal object. This is for template object. So the only thing that you need to do is pass the data type for the object. Now the object will be an integer type. If you want it to be float, you can also float. Like it depends on what data type that you need. If you want integers, create an object with integer. If you need float, you can also do that. In float OBT like this. Just you need to pass the data type as an parameter. So this is how we will create objects for template classes. So does it make sense? Everyone understood till now? Just we had 1 minute before going into STL. Everyone understood function templates and class templates. Sorry guys if I was very quick. Hope you understand the time was very low for me. So this is how this is class templates. Just so you doesn't need to do anything like this. You can simply do it as a in the curly braces, pass the data type as a parameter and normal object name. If you want parameters for the object, you can do like this int ob of 2 3. So if you are passing float values, ob of now you need to change this to float like this. It depends upon the values that you are passing with the object. So cool. I guess everyone understood the class templates as well as function templates. Now we'll get into the main part. Oops, sorry. So guys, is the screen visible till now? The class templates code,
Yes, visible.
right? Visible, right? I just forgot whether I had kept this here. Okay, cool. So we had just completed templates, introduction to STL, as well as examples for STL. Now our task is to explore more about STL. So what's the full form of STL? Everyone type in the chat box so that I can know whether you had the class or not. What is the full form of STL? Standard template library. Nice. So now it makes sense. So what is STL? It's a collection of templates, library of templates, standard, which means we can use it in our programs as well. Standard template library. Now it's a collection of some predefined functions. We can use some predefined functions like sort and all those stuff, which will be given by compiler for us directly instead of we doing everything. Okay. Now the components of STL. So there will be like around 4 to 5 components, but today we will discuss around 2 components. So the 2 components that we are going to discuss today will be containers and algorithms. So these are the main components of an STL. So first we are going to discuss about components. So if you can see components, these are some types of components: vectors, stacks, queues. In these three, I guess you heard about stack as well as queue in data structures, right? Data structures using C++, stack, queue, settler queue, and all this stuff will be. Now we will implement. So the first component that we are going to learn is a vector. Cool. Sure. Okay. Okay. The component that we are going to learn right now will be vector. So what is a vector? So what is an array? First of all, just type it in the chat box. What is an array? Just type it in the short form, not necessary to like type entire paragraph. What is an array? Just basic definition. Collection of same data type. Exactly. Collection of elements of same data type, right? So the main now let I will tell you the drawbacks of array. So the first drawback of array is it has fixed size. So what is meant by fixed size? Whenever you are creating an array, you need to create like this, right? You need to specify this part. If we don't specify this part, the compiler will throw an error. This is the size of the array. If we created an array of 10 elements, that's it. The entire program, you can't change the size of array. You need to fix it for only 10 elements. So that is an issue, right? We can't change it size randomly. I mean, we can't add new elements. We can't delete elements. Once an array is created, the size has been fixed. You cannot modify that. You cannot increase or decrease. The size will be fixed as it is. So a vector is simply, to sum it up in 2 words, it is a dynamic array. That's it. Normal C++ has static arrays. A vector has dynamic arrays. So what is meant by dynamic array? This drawback will be fixed by vectors. So a vector has dynamic size. So what is meant by dynamic size? Simply to understandable words, dynamic size is nothing but the user doesn't need to explicitly mention the size of array. Like an array of 10 elements, an array of 15 elements, like that. The compiler will automatically adjust the size of array based upon the number of elements. There are 2 cases for arrays. Take an example, you created an array of 100 elements, but you only used 3 elements. So there will be 97 unused locations, right? You are wasting so much space. Another case will be you need more space, like you need to fit for 120 members. You cannot do that in arrays. But in vectors, what you can do is you can add or delete data, and the compiler will automatically change its size depending on the number of elements. So that gives it a dynamic nature. So that's it about simply vector. It is a dynamic array. The big advantage of vectors over arrays is dynamic size. Dynamic size, you can you doesn't need to mention explicitly like a size of 20 elements, 30 elements. Vector will automatically do. Now let's see how to create a basic vector. Everyone understood about vectors? Just what is a vector? Simply dynamic array. Okay. Now let's see how we can create an vector. Space std int main. Uh, so this is how I will create an array, right? So int 10 equals to 1, 2, 3, 4. Uh, this is how we will create an array, right? Okay. So the first thing that you need to do if you want to use vectors will be you need to import vectors. So to import vectors, you need to simply type it as hash include. Or the typing was very bad today. I don't know why. So it would be hash include vector. Nice. Okay. Now tell me. I need to create a vector, right? Nice. To create a vector, you need to use the imported keyword. And remember, vector is an part of standard template library, which means it is a template class. So to use the template class, we need to create an object. To create an object, I need to pass the data type. So a vector of int is the data type, and it has the name v. Understood, everyone? So now tell me, what is a here and what is v? Okay, the first question would be, this is the creation of a vector int v. If you can observe closely, I haven't specified any size of the vector like v of 10, v of 20 like that. I just created vector int v. Initially the size would be 0. As there are no elements yet, I will tell you how to insert elements, delete elements and all the stuff. So now tell me, what is a? Array or vector? In the chat box. Please be quick. What is a? A is array. Cool. Okay. Now tell me, what is v? Nice, nice. V is vector. Cool. So fundamentally, there is no difference between arrays and vectors. This is the just implementation of vectors. Now, to insert element into vector, I need to use a predefined function called v dot pushback of 10. Uh, I will write some functions here. So pushback is to insert an element at the end from the backward of vector. Uh, Another function would be size. Gives the size of a vector. Simply how many elements are there in the vector. And other functions, and there will be some pop function, I guess. Push front, you can also push from the front and all the stuff. That's not the main role today. Just in brief introduction to vectors would be enough. So v dot pushback of 10. Oh sorry, I will also push another element, pushback of 20. Okay, now what I will do is I will print the size of vector. Now tell me what will be the output. C dot v dot size. So remember, guys, all the template. Whenever we use templates like containers and all the stuff, there are some predefined functions that you need to remember, like to insert elements. To if you are familiar with Python, it's almost like that. To insert, we use an append, right, in the lists. So similarly for vectors, you need to use the function push back. It's a predefined function, push underscore back. Don't merge them. So this is also another predefined function, v dot size. What will be the output of v dot size? Any guesses? See out v dot size. Cool. The size would be 2. That's it. Now tell me, see out size of a by size of a of 0. What would be the size of this array? Who will tell me? What is the size of this array? A of 10, 1, 1, 2, 3, 4. What is the size of array? 4. 4. So this is how. So the answer would be 10. Let me uncomment this. So the answer is 10. So this is the problem with arrays. Even though I created 10 array of size 10, I have only utilized 4 elements. But as I told you earlier, once the array is created, it's created. You can't modify. Even though you use 4 elements or 1 element, the size would be fixed. It's always 10. So okay, that's the main problem with array. But here, if I add another element to this vector, just observe this magic. Push back of 30. Now see what will happen. The vector size 3. So the compiler will auto adjust the size of a vector. So this is the main advantage of vector over an array. It has some dynamic features that makes it very fast and as well as very efficient in the memory terms as well. If you want to learn more about vectors, I will give a links. I mean, this is 1 hour session, right? I can't tell about vectors entirely in just 2-3 minutes. This is the fundamentals that you are required. Cool. So everyone cleared with vectors? Just give it a yes, so that I will move into the next one. Everyone cleared with vectors, how to create a vector and all those stuff. Okay, so the vector part is completed. So the next part would be stack. Okay, I'm getting data structures vibes already. Okay, now let's see how we can see the magic of. Now you will understand the power of C++ STL. Vectors is not enough to show you the power of C++. Okay, uh, I will. First of all, I will just show you a program. Please wait. So everyone, are you familiar with stack? I mean, sorry, do you know about stack, right? Data structures in the starting. At least some basics of stack. Okay. So simply stack is a data structure. It is one way. Like you can only insert the elements from top. Only one set elements. Just understand a bottle. Place 5 coins. One coin, top of another coin, top of another coin. So it is only one way. You can't keep it from bottom and top. Just a one way. So that is a stack. If you are familiar with some data structure program, the stack program would look something like this. Okay, don't intimidate seeing this. This will be the function to insert an element into stack. Okay, this is the function to insert an element into stack. This is a function to delete an element from the stack. Okay, this is the function to delete the element into stack. This is the function to insert an element into the stack. Okay, this is to display and all this stuff. Looking good now. Very small program. Stacks. This is just to insert an element. Now what we can do is basically we use arrays to implement stacks in programs, but if you use STL, you have directly something called as stack. So what you can do is simply you can import stack instead of taking an array, creating an array, inserting elements, popping elements, checking whether it's underflow or overflow and all those stuff. You can simply import directly stack. So let's see the magic of stack. Okay, now tell me, I will just observe your skills. As I told you already how to create a vector, now tell me how to create a stack. Just observe the syntax closely. I have imported the stack just as before I imported the vector. Previously I created a vector with some syntax, right? Now tell me how to create a stack. Oh, I'm very excited how many people will grasp how to create a stack using the STL syntax. How to create a stack. Come on, type it in the chat box, quick. Stack int s. Fine. Stack ob. Okay. It's almost correct, but you need to also specify the data type of ob, right? You can't keep the empty braces. int stack a. Oh my god. Okay. It clearly shows. Please watch the video by zooming your eyes. You are not watching closely. So to create a vector, I did like this vector int a. Similarly, to create a stack the data type of elements that it stores, stack name. That's it. So S will be the stack name. Cool. So many people. Very good. Very good. Okay. Now to insert an element, uh, just wait a minute. I will bring that code back so that I can show you the power of C++ STL clearly. Uh, in general world C++, many people will ignore STL like they think it's hard. Okay, so is it visible? So this is the function. Uh, sorry. Uh, so this is the function. I will paste it in the chat box as well. So void push. This is the function that you need to write if you are implementing stack using arrays. But if you use STL, what you can do is instead of writing this entire code, I can simply to insert an element as dot push to. That's it. It's done. So the element will be inserted. You doesn't need to write this code and all those stuff. You simply push is a predefined function right now. Why? I have imported stack. So push will be a predefined function. So to insert another element, s dot push. Oops, sorry, my excitement is what is it? Not allowing to type. So to insert another element, s dot push again. To insert another element, another time s dot push again. That's it. How many elements you want to insert, you can simply use s dot push, s dot push, s dot push. That's it. Understand? This is how uh, this is how you would insert an element into stack. I think you are not believing me, right? That's it. In just a one line of stack, I created a stack. In just one line of code, I've inserted an element into stack. Nice. Okay. Now tell me, I will see who will say the correct answer. So top is another predefined function. It returns the top of the element in the stack. Now what will be the output? If you know data structures, you can say it simply. What will be the output of s dot top? Wow, so many answers already. 5. Cool. So simply the latest element that is being inserted into the stack will be top of the stack. That's it. If the output came 4, the code will be right. Else wrong. Magic. That's it. That's it. We have created a stack, inserted the element into stack. Now also displayed the top of the element of the stack. Now to delete, assume that function. How to delete an element? Any guesses? What will be the function? I'm seeing the chat box right now. Pop. Cool. That's it. Pop. Uh, so simply s dot pop. So remember, stack is one way, right? So always the top element will be automatically deleted. You doesn't need to mention it explicitly. So now tell me. So that's it. S dot pop. It will delete the top element. Now tell me what will be the output. What will be the output for s dot top now? We'll see who. Cool. Answers are coming. 3. Nice. Now let's see what will happen. I will will just uncomment this. Uh, so the answer is 3. Claps, everyone. Nice. So many people are interacting. That's very nice. I will delete another element. Now let's see what will output. 2. That's it. Nice. Okay. Now, if we want the number of elements in the stack, I need to use a function called. Any guesses? What is the function that we need to use to get the? I'm about to reveal the answer right now. To get the number of elements in the stack. Any guesses? What is the function? Count. Count. Size. Perfect. Exactly. So why the size would be 1? I had inserted 3 elements. I deleted 2 elements. So the size would be 1. That's it, guys. You have successfully compressed your 70 lines of program into less than, if we compress this, so you can take it to under 10 lines. So this is the magic of STL. Nice. Excited? Not bored. Now, okay, I haven't getting any responses. Cool. Okay, now let's see how we can create a queue. To create a queue, I need to import queue. That's it. To create a queue again, queue int queue. Uh, queue dot. What would be the function to insert into queue? Stack has push and pop. Queue has front and rear, I guess. I just can't remember correctly queues. The push won't work, I guess. Insert? No. Well, let's try. I don't know, guys. To be honest, I haven't did the queues in the recent times. Okay, looks like it's working. Uh, nice. Okay, it's working, guys. Okay. To insert element, same function. I don't think it's correct. Just give me. I will search on Google. Q in STL. Uh, it, the push function is working perfectly. Okay, I'm correct. To insert an element, you need to simply use push. Okay. Now tell me, Q. Do you know Q? Yeah, the function name would be NQ and DQ. Perfect. Uh, Now tell me, what is the difference between stack and queue? Stack is only one side open, right? You can perform both insertion and deletion only from one side. But queue is what is, how can I say? It's double open, which means you can insert from one side, remove from one side. Okay, you can insert from right side and delete from the left side. So they're called front and rear, right? So what I will do is now I will push three elements. Sorry, uh, do not push 4. Okay. Now tell me what would be the output for q dot front, c dot, q dot, where not back. I guess the function name would be back. Okay. Now tell me what would be the output of q dot front. Q dot front would be 2. Okay. Okay. Let's see. Absolutely. So q dot front would be 2. Now tell me what will be the output of q dot back. That's it. That's it, guys. That's it about queues as well. Keep in mind, I'm not telling right from the start to end. Only the stacks would take around 2-3 hours in STL to finish. I'm just giving you a brief idea so that you can use this and you can research yourself. Keep in mind, whenever you're learning, keep that in mind. So, okay, now tell me, containers clear, vectors, stacks, and queues. How to create basic vectors, stacks, and queues. Everything clear? Okay. Thank you. Thank you for the responses. Okay. Okay. It's time to tick. Okay. The containers part is over. Now the part would be algorithms. Okay. Are you excited now? What is your current mood? Please tell me. Still we have 15 minutes. I will complete as early as possible. I hope I cleared that myth like STL is hard. Don't think like that. STL is very, very easy. STL is very, very easy. In even I prefer STL over Python. Python is very Python has all functions, but it's very, very slow. Like in competitive exams, if you use Python, that's it. You won't qualify. In competitive exams, you need to qualify. You must need to use C++ or C. C doesn't have STL support. C++ has STL support. With the STL support, now I will show you the real power of STL again. Now it would be very easy. Like till now, I have just shown you stacks and queues, all this stuff. Now I will tell you some real functions of algorithms. Okay, cool. Let's start then. Okay, I will copy this code so that I don't need to reuse it. Okay, here comes the trump card of C++ STL. So what are we going to discuss right now? Everyone, please with your hands type that word again on the comment box. What is that word? What are we going to discuss right now? Algorithms. What? Alg- oh my god, this guy is sleepy. His brain has turned into something else after watching this tutorial. Okay, okay, jokes apart. So what is meant by an algorithm? An algorithm is nothing but is an algorithm. Okay, I hope it made some sense. An algorithm is an algorithm. Simply like it is some predefined function instead of doing something. Okay, now tell me. I have a question for you. I have a question for you. How many of you know bubble sort? Bubble sort. Raise the hand. You can also raise the hand. If you are in laptop, you can raise the hand. Forgotten. Okay, okay. It doesn't mean the program. Have you heard about bubble sort? At least tell me that. So what bubble sort is used for? Where we use bubble sort? Like what is the use of bubble sort basically? Any idea? What is the use of sorting of elements exactly? So to simply sort an array, we use bubble sort. So okay, now I will show you the code that is required to implement bubble sort. Okay, are you able to see the program? So this is the program for bubble sort. Tell me how many lines it got. Just the program. I haven't included main or anything else. Just bubble sort. This is the code for bubble sort. So essentially what bubble sort do is it sorts an array of elements in either ascending order or descending order. Now let's do the same program using C++ STL and let's see how much size it got compressed. Okay. Oh my god, I need to retype it again. Oh, this is the annoying thing of C++. They need to remove this as Python don't have this using namespace std. Come on, main. Okay, nice. Uh, okay, I will create an array of elements. Array of size of 5. The elements would be 5, 4, 3. Oh my god, the Python what annoying. Okay, cool. Okay, now the thing that I'm doing is I have created an array of 5 elements, array of size 5 elements. Generally, what we will do is we'll create a function called bubble sort and call the program like this, right? Bubble sort of 5. But now I will show you the sorting program using C++ STL. I need to import something called as algorithm. So this is the header file that you need to use in order to use algorithms. So there are many algorithms, predefined algorithms in C++. You can Google for the list of items. There are so many algorithms. Okay. Now what I need to do is I will also create in a vector. Okay. Now I will create a vector from this array. Vector in A and B of size A comma A plus 5. I hope it made some sense. I don't know whether it work or not. Just I will see. Please wait. I will explain what I'm doing. Don't worry. Cool. It's looks like working. Okay. Uh, just see, I have created an array of 5 elements, 5, 4, 3, 2, 1. These are in descending order. My task would be to convert these elements into ascending order without using bubble sort and all those stuff. Just STL. So I have created a vector from this array. To create a vector from an array, this is the syntax: vector, int, vector name, and the number of elements you need to like. If you need to create a vector from first element to fourth element, you would give a comma a plus 4. This will create extract the 4 elements from the array and create a separate vector with name b. But I need an array of 5 elements, right? So I simply made vector into v a comma a plus 5. Okay. Now a now tell me, a is an vector, v is an sorry, oh my god, a is an array, b is an vector. Now to sort, now you have benefit of vectors, right? So vectors, there are so many predefined functions. Also, I have imported algorithm, right? So instead of doing this vector thing, I can do directly, I guess. First of all, I will show you without vectors. After that, I will show you with vectors as well. Now to sort an array, there is a function called sort magic, C++ magic. A comma the number of elements that you want to sort, right from the start of the array to end of the array. Now I will print the array. See the magic. Int I equals to 0, I less than 5, I plus plus. Cout a of I, and then so this is the only thing that I have done. I haven't wrote any code for this sort program. The number of elements that you need to sort. A means first element, a plus 5 means right from the first element to fifth element. Please sort. Now let's do the output will be, there you go. The output is 1, 2, 3, 4, 5. The array got sorted. That's it. To sort an array, this is the program. You doesn't need to write bubble sort, selection sort, mid sort, insertion sort, radix sort, uh, all those. That's it. This is the program to sort an array. Sort. Okay. If you want to sort only the first 3 elements, you will give a comma a plus 3. Now see the output: 3, 4, 5. The remaining elements stayed as it is. Only the first 3 elements got sorted. That's it. You would simply, that is the power of algorithm. This is just an example of algorithm, just one, not even 1% of the algorithm package. The algorithm package contains loads of functions, like searchings, sortings, and all those stuff. Clear? Understood the power of algorithm? This is how we can sort an array using algorithm. I haven't wrote anything, like anything, just I use the sort function. If you are familiar with Python, you would be obviously know this thing. Like Python also has, right, something. Python is it's in separately. Don't compare it with these statically typed languages. But the, I think you got my point. You can also use C++ like Python, even better. This program would compile way faster than the same sort program would do in Python. Python would take ages, but C++ does it instantly. So this is the power of C++. Still, don't ignore this. Now I will tell you another thing. What is? Let me take a look at agenda. Yep. Okay. Okay. Now my task is to reverse this array. Okay. To reverse this array, and which means I need to print this array in reverse order, like 1, 2, 3, 4, 5. So to do the reverse, I need to use the function reverse. That's it. Completed. 1, 2, 3, 4, 5. Instead of keeping this handle, I will keep a space so that it would be very clear to see. So this is the output, reverse. The reverse function would reverse the array. That's it. This is another algorithm. So far, what are the algorithms that we have discussed? Sort, reverse. Understood? Keep in mind, you must need to pass two arguments, starting array name and the number of elements that you want to do, a comma a plus 5. Understood, guys? Reverse and sort, both are clear? Keep indicate with emoji. No text, please. No emoji gang. Emoji gang here. Fire gang. Okay, even better. Fire gang. Okay, this is another sort algorithm. This is you can use this sort algorithm, reverse algorithm. The next thing that I will show you is count. Come on, count. Now, this is all features of Python are coming into right. Let me write a Python program. I guess you are familiar with Python. I guess this is how we create a list. To count the occurrences of an element, what is the function that we use generally in lists? Like taken, we have a list 1, 2, 3, 4, 5, some elements. You need to count how many times a specific number has been repeated in the array, right? Uh, do you understand my task? I had an array. I need to find how many times a specific element has been repeated in that array. Okay, my task is now to find how many times 4 has repeated in the array. What is the answer? How many times 4 has repeated in the array? 3, right? Okay, now I will write plain C++ program to solve this. First of all, I will create an iterator, I less than 7 elements, I plus plus, and I also create a count variable, int count equals to 0. I will check if sorry, the name of array a of I equal to 4, then count plus plus. And after this for loop, I will print this as cout count, right? Okay, let's see the output, right? This is the program, right? This is the program that we use to count the occurrences of an element from an array, right? Now we have wrote this much of code, count, a for loop, and all the stuff. No need with STL. You can use the function called count. So a dot count of I honestly didn't remember the syntax. I guess it's directly like Python, but I don't know if it will throw me an error. I will fix. Yes, please don't think in another way. I haven't prepared it to be honest. I also have semesters right. Request for member count. Okay, it's throwing me an error. So that a comma a plus 7 would be fine, I guess. So okay. Don't need to place like Python. Okay, I just obsessed with so much of Python, so I just added a dot operator. You don't need to use dots in C++. That's why this is a difference between C++ and Python. Observe closely. In Python, you would use array name dot function name. In C++, count you pass the name as a parameter. That's why a comma a plus 5 like this. I forgot this thing. Okay, you need to pass count of with count. You need to count what you need to count in the array of a comma a plus 7, right from the first element to right from the seventh element. You need to count the occurrences of 4. How many times? 3 times. That's it. Just a single line of code. That's it. This is how count function works. That's it. Hmm? Liked it? Reached your expectations of STL? This is typically exclusive to Python. People think like only Python has shortcuts, the inbuilt functions. No, not true. C++ is even more powerful than that. Now you can also find elements. If you use find, it will return this index of an element. Okay, compiler is very buggy, but I don't have choice. Okay, okay. Don't don't feel so much of scale like this. It's just the hex code, which means it is returning the address of file, right? Got it? So what does a find function do is it will search if the element, it will return the element index. So it is looking like a pointer address, like it is looking like an address. To get the value from the address, I need to use star in front of this. So fine, that's it. Oh, sorry. What the find? Okay. Got it. It will just return true or false. To get the index of that element, we need to use another algorithm called binary search. Okay, this is the last thing I will tell today. Don't worry, I will sum it up. Uh, Sorry. Have you heard about binary search and linear search? Hmm? Binary search, linear search. Tell me in the chat box. Just another couple of minutes. Sorry if I'm late. Binary search and linear search. What these both things do? They will simply find the element from an array. If the element is in the array, they will return the index of that element. If not, they will return false. Right? Okay. So now let's see what is the code that is required for binary search in just plain C++. So this is the code that we need to use for binary search in C++. I hope it's visible. Cool. Is the screen visible? Okay. So this is the code that we need to use to to write a binary search program, right? See how much of space it is taking. What it do? It will simply return the elements address. Using C++ STL, you can reduce this as there is a function called binary search. Directly we can use binary search. Binary search. Cool. So 5 is present at index 0, right? So that's why it's 0. If I give 1, it will print out 6. Oops. Okay. What is happening with this array? Uh, Binary search. Okay. Just give me a minute. What's happening? Binary search. This is spelling okay. It's okay. Looking fine. Okay. I guess there will be some syntax modification. But we can use binary search directly. Let me do it another way. Maybe just wild guess. Okay, not this way. As I told earlier, this is exclusive to Python. In C++, you need to loop like this. What I will do is, so for binary search, maybe it's exclusive to vectors, I guess. I need to convert this into vector before doing so. Binary search. Okay. So I guess I need to convert this into a vector. So keep in mind, some won't work on arrays. As a statically typed, right? We need to use. I will convert this into an array vector. So okay, not an issue. Understood the class, guys. Anything learned new? Satisfied? Sorry, actually this is a very fast session. I haven't have so much of time to explain detail. Uh, I don't know if it will work or not. Uh, Not sorry. Maybe not working. So maybe I need to import some other thing. Research. Okay. Yeah. Got it. I got it. I guess I got it. Maybe it's returning a boolean value. If binary search of a comma plus 7 comma 5. What I'm doing is maybe I'm checking just is it returning a boolean value found. Just I'm checking, not sure. Okay, now let's see. If this prints found, it's boolean. Okay, it's not printing anything. I'm not sure why it's maybe okay. I'm using this online compiler. Yeah, that's the issue. Maybe. Yep. You need to use this as a system file. Right? I need to install this algorithm package. Not all algorithms are available in online. If there is dev C++ in your compiler, this is the syntax. Don't worry. I'm sure. I'm sure. Like some work, some don't work. Don't worry. Binary search a comma a plus how many elements comma the element to be searched. That's it. It will return the index of that element. Hmm. That's it. I don't know why it's not working here. I'm not sure. Comma plus. Okay, not sure. Hope that's it. That's all about today. Have any queries, guys? I hope it made some clear. At least you learned something new. Maybe. Don't think about STL is hard. STL is only like top. STL is very easy. Okay. Please give your feedback in the chat box. Also, after this session, you will receive a mail from Google. Please give some positive response over there so that our DSC might get global recognition. I know very low people, but at least 40, right? Okay, just to submit this to sum up the session. So these are the things that we learned today, right? Introduction to STL, how to use the templates, examples for templates, components of STL, containers, vectors, stacks, queues, how to create, how to insert elements, how to delete elements, and algorithms, sort algorithm, reverse algorithm, count algorithm, find algorithm, binary search, and all those stuff. Cool. Thank you, everyone. Sincerely, thank you, everyone. Honestly, I'm not expecting this. At least, like it's very low, right? I mean, in the midst of examinations, conducting classes is not good. But anyway, thank you. If you have any queries, feel free to ask right now. Anjali, you can stop the recording.